think I was today. All right. Notes 4-5. This is going to be round 2. What we are learning and practicing now is called integration by substitution. We started it yesterday, so part 2. Okay. So with a formal change of variables, you completely rewrite the integral in terms of u and du technically, or any other variable. Could use the t that we have been working with. It's just not going to happen. So we could use t, but that's less popular, and so especially for those of you, well, on the AP exam, they're going to use u. In calculus, we use what we call a u substitution. You're going to see this in Cal 2, and those of you that are going to continue on, u substitution is the most popular. So I'm going to just show you how we're going to kind of transform what we've been doing. So we've been looking at things in this pattern. So f of g of x times g prime of x dx. Good luck. And we're going to rewrite it like that. That's how I feel. Ridiculous. All right, so notice what we're doing here. We did this before with t. The reason I did it with t is just because that's how the notation for the second fundamental theorem of calculus works out. We use t in that formula. So yesterday I wanted to start you with the second fundamental theorem so that you could get that feel for just undoing what we were doing just the day before. Now I'm going to try to graduate us up to where we're thinking about, instead of t there, we're going to think about the inside as being u and the g prime as being the du. Okay, so we're going to identify a u, and then we're going to need that du to go with it. And now we're going to get to the fun stuff. So what in the world was going on every time we didn't have a number? I know, it wasn't working. We were missing numbers for our g prime. So let's say that we've got this now. We've got the antiderivative of the square root of 2x minus 1 dx. You didn't have any options for this really before because there's no like chain rule-esque rule for integration. So there wasn't like just a pattern, bless you, that you could follow. So whenever we're looking at this, I still would love for you to do like the whole rewrite with the radical as a first step, because just we forget to do that. So this is actually like thinking about 2x minus 1 to the power of 1/2 dx. I still need the integrand because I haven't integrated anything. I'm just playing with formatting. You have nothing for this situation. You can't distribute that exponent. It doesn't work like that if you've got addition or subtraction there. So you have no way with your current skills to be able to integrate this. So that's when we're going to need to make a u substitution, or before we were calling it pick a g of x, like find an inside part. So instead of identifying a g of x right now, you're going to tell me what u is. So you don't have a lot of choices here. Perfect. 2x minus 1. I'm limited on options. There's not a lot of parts to this one, so there's not a lot of inside parts that I can play around with, like what should u be? I don't have a lot of choices here. So d of u is what? Don't lie to me. 2. Okay. derivative of u. Okay, so my du is 2. When I go to rewrite this, now I have u to the 1/2 but the du part, if I'm going to write du, right now, that's equivalent to 2. So I can't just put a 2 here without changing the value of this integral. So what I'm going to need to do is, if I'm going to multiply this by 2, I need to make it feel like I'm really multiplying by 1. Okay, thank you. Okay, you. To go to the front office after class, which was apparently so urgent that we needed to call me 3 times. So anyway, so du is 2. I want this to feel like a 1. So what can I multiply by? 1/2. If I'm thinking of du as having a value of 2, and I need that inside of my integral to complete my pattern, then I need to balance that by putting the reciprocal of whatever number you're missing out front, so that you haven't changed the value of anything. I need to pretend that du is 2. I need du to be 2, but it's not 2. It's, in this problem right now, the way it's written, it's 1. I got like a 1 back here. So if I need to think of it as 2, if I'm going to use the pattern and pretend that it's 2, then I need to balance that or counteract whatever missing constant I have with the reciprocal of that number, so that I've really just changed it by 1. At that point, I'm going to leave the 1/2 on the outside. I'm going to integrate u to the 1/2. U to the 1/2, which is square root of u, but using our power rule, I'm going to go up a power, so 3/2, and I'm going to divide by my new power. Plus c. Now, you need to go back and fix that u. I'm not saying that you need to go back and like clean this up or simplify it. I'm just saying you can't leave it in its u substitution form. You're going to need to go back and plug in what u was. So 2x, 2x minus 1 to the 3/2 over, and you could leave it like this. And that is our antiderivative. You could simplify it. Do y'all want to simplify it?
No.
If you do simplify it, optional, you have the 1/2 multiplied by the reciprocal, because that's in the denominator. So you're really going to be and then of course that would go.
Where'd you get the 1/2 before the s?
That I balanced because I didn't have, my du was 2, but to start the problem, I didn't just have a 2 to use. So I'm going to pretend I need du to be 2. So I'm going to think of du as having a value of 2. But so that I don't change my integral as far as numerically the value of it, if this is going to be a 2, I'm going to multiply by a 1/2 so that it equals 1, so that I've changed it by 1. I need a 2 inside, but I can't just multiply by 2 for no reason. So I'm going to balance it with the reciprocal on the outside so that really it's mathematically equivalent to my beginning point, but to complete the process using the pattern, I need the g prime to be exactly what my g prime is after I take the derivative of it. So if I'm missing a number, I fix it by putting the reciprocal out front. So if I'm going to let du be something that's not there, then I need to balance that with the reciprocal out front. Yes.
So this is like, instead of making the u and the du, or instead of making the equation like the u and the du, this is kind of like forming, it's like what you have to do to make that true, right? So like,
Yes.
all of this is what you have to do to make sure that du is 2.
Right.
It wasn't like that earlier.
Right, because the DUs, you had them. It was what, like the examples we did yesterday, when you look back,
You see what I'm trying to say?
like I had the G prime. So my G prime was 5. Oh, look, I had a 5. Great. I didn't have to play any balancing act games here because I had the G prime that I wanted. And even up here, my G prime was 2x. Well, I had a 2x. If this had just come out to be x, then I would have needed to put a 2 there and put a 1/2 here to balance it. We're gonna do more. Okay, we're gonna do more. Do y'all believe if you take the derivative of this, you're gonna get what you started with? Do you want to do it to see it?
No.
None of y'all want to do it? Aww, disappointed. I was hoping y'all would be like, yeah, I want to see that it works.
Well, but all you have to do is just.
Imagine. Use your imagination. Because when you bring this down, that 3 is going to cancel. How is the 1/2 going to cancel? Right, but where's the 1/2 going to go? Because when I bring that down, the 3 is going to go, but where? The derivative of the inside. Because when you do chain rule, you're going to multiply by the derivative of 2x minus 1. So that's where the 1/2 in the exponent is going to disappear. Okay, so yes, it will check out, even though you didn't want to do it. All right, fine. Fine. All right. Next. Appreciate that. Okay, I'm just going straight to like one that's kind of tough. Y'all ready for this?
Why not?
Why not? I know. I like that.
Skip the run.
That's true. I like it. You're speaking my language right now. By 5 years old, be working on calculus. All right, so, well, let's see.
Let's just do it by ourselves.
You're not gonna,
It's not to say we did.
you're,
Bet I'll do it by myself.
Check
Bet.
it.
so, hopefully this mic isn't picking up anything but me. So you would be, I'm guessing, just because I'm pretty sure I know what y'all are gonna say, like let the inside part be that, but then du is 2. Well,
Or,
what about
I was going to say it.
this x?
I seen it. I was going to say something.
Because that x is not going to be absorbed into my du. Okay, I can't get rid of the x. And this is where I need to really emphasize and clarify something. You cannot say, well, you know what? I want that x to go away, so I'm going to put a 1 over x on the outside. Never. No. Don't do it. Okay? Because then you're changing the value of it because you just want x to disappear. Doesn't work like that. So in this situation where you've got a variable that's not getting picked up, so we're missing a 2. That's a problem. Okay? So we don't have a 2. We just learned how to deal with that. Okay? With the balancing with the 1/2. But we have a bigger problem this time. Not only do we not have a 2, but we have something we don't want, which is unusual for us so far. So this is what I'm going to need you to do. We can't separate it into 2 integrals because I can only do that over addition or subtraction, and if I'm multiplying, if I have a product, I can't just separate it. Wish I could. That would make life so much better. We need to make a substitution
Okay,
for x.
okay, it's going to be half. X equals half.
Rearrange this equation. So solve it for x.
X equals negative half.
Actually do this right now. So you're subtracting 1. So you're going to have u plus
Oh,
1. And then you're going to divide the 2 off of it. So rearranging that u substitution piece gives us that x is going to be equivalent in this problem to u plus 1 divided by 2. So when we come down here, x is equal to u plus 1 divided by 2. And then this is the square root of u, which we're going to change to exponential form here in a second, and then du. But right now, du is 2. But I don't have a 2. So that's when I hit the front of the integral with the balancing act. So that if I'm thinking of du as 2, then I balance it with the 1/2 on the front so that I haven't changed the value, it's just 1. You've got to clean this up. There's no product rule with this right now, so you need to fix it. So we've got to play with the formatting. Keep your integrand because we have not integrated anything.
2x, just 2x, over 2, right?
Hold on. We have u to the 1/2 here. I'm going to put that over 1, and then du. We could just write du because I've balanced. Yeah, distribute it. Okay, so I'm going to multiply these two fractions together in the numerator. I'm going to have to multiply u to the 1/2 times u and u to the 1/2 times 1. And when you're multiplying fractions, you just multiply across. So then in the denominator, I'll have 2. So let's do this. U to the 1/2 times u gives you u to the, it's like you're adding 1. So when you multiply, you add exponents. There we go, 3 over 2. Plus 1 times u to the 1/2 is u to the 1/2. All over, technically 2. Okay, here's the deal. We talked about once upon a time how if you had constants in the integral, you could bring it out. Like if you have a number in there that you don't want, you can bring that out in front. So like if you were going to integrate 5, I don't know, x cubed, we said that that was equivalent to 5, let me put my dx there. So these are mathematically equivalent. So to make this simpler to where it doesn't look like I've got, division, I don't have a fraction,
Multiply by 2, by half.
bring out 1/2. Look at it like you're removing 1/2, okay? Because this is, and I don't want to like make you rewrite too much, but just so you can see it, this is the same thing as this. And then you've got this 1/2. So this is the 1/2 in front. This is the 1/2 that's giving me the divided by 2 piece. So I'm going to bring this in front. So in front, I'm going to lead with a 1/4. Very, very good. I'm going to lead with a 1/4. Well, we haven't integrated anything yet, sadly. Okay. Please ask me if you need me to explain anything. I mean, right now I'm not saying like you should feel like a rock star at this, like you're not going to, but I just need you to like be with me. Michael, question.
So how come du isn't 2? Because
It is 2.
Okay.
I'm just not writing 2, but du has a value of 2 for this problem.
Why aren't you writing?
Well, the same reason that I'm not writing that u is 2x minus 1. Because I'm trying to do a change of variables so that I'm not looking at this in such complicated terms. I'm trying to get this in really simple terms and get as many numbers out of it. So I want to substitute so that all the complicated stuff just looks much, much simpler for me so that my brain can process this integration. Yes?
Okay, so the whole point of that, putting the 1/2 in front was to cancel out the 2, right?
This first time, yes.
Okay, so then on the very bottom, there's still a 2, very bottom. Very, very bottom.
Some of the last
Yes,
step.
there's still a 2 there, but now it's 1/4, so how does that cancel out the 2?
I have like 2 1/2s right now.
Yeah.
This 1/2 cancels out my du, the 2. This 1/2,
Puts
It's-
it all under 2.
yes, is my substitution divided by 2 from up here that I'm relocating out front, taking advantage of this rule that says I can take coefficients on variables and move them in front of the integrand. Okay. From here, easy as far as it's just power rules, okay? So from here we can actually integrate. I'm gonna have 1/4. This is gonna turn into u to the 5/2 over 5/2, plus u to the 3/2 over 3/2, all of this, plus c, and obviously I did not manage my paper well. I know. All right, so then my answer, I need to go ahead and back substitute the u, and as y'all get better at this, when you go from here to here, you can start replacing the u already. You know what I mean? Like you'll start to say, okay, I'm gonna take u, I'm gonna go up a power, divide by the power, okay, but it's not gonna be u. You'll start going straight to,
2x minus.
yeah, this piece. And a lot of times this will be the first step that you start skipping, like once you really get more comfortable with this. And this time, I don't even feel like taking the derivative of that to make sure it checks out, but we definitely could. Oh, now you want to. No, I refuse. I refuse. You did not want to participate when I was excited about it, so no. I'm gonna be like that. All right.
About it now. Love that.
Too bad. Okay. Y'all try.
Is there a way to simplify that?
Yeah.
Oh, wait, to simplify that?
Yeah.
Take the reciprocal and put it in front. Take the reciprocal and put it in front. You could distribute the 1/4.
Because I did it like another way, and I don't know if that was equivalent. Probably isn't. No.
I'll look at it. I can look at it.
I got like a.
Where's everybody at today?
FPS. Okay. Do y'all want to try this one?
No.
I hate you.
You see trig functions, you don't like it? Okay.
Exactly how it is.
Okay. Well, y'all know me. Y'all know me enough to know. Hopefully, what do you think I'm going to say about this?
Should we simplify that to,
No simplifying.
You're gonna change it to cosine.
no.
Stop.
Put the square on the outside of it.
No. Oh, right. Okay. Rewrite.
You're right.
Rewrite. All right, that helps you see like the inside part versus outside part. I highly recommend it. Please do it as often as possible. Just like, you know, on these, I'm like, oh, rewrite it in terms of that power. Like you always want to rewrite more complicated expressions when possible. Okay, yeah, so tell me, what do y'all think? So u should be sine 3x, and then du would be,
Negative cosine.
No, it's just
Cosine? Oh, yeah, just kidding.
it's a derivative. If it was antiderivative, it would be negative. Okay, so how am I doing on my du? Do I have what I need?
No, you need it.
Okay, so this is the du, almost,
Kind of, sort of.
but I need to think about them with a times 3. And if I'm going to pretend that there's a times 3 here,
You gotta put the other thing in third.
then I'm going to put a 1/3 there. So my new integrand is going to be a 1/3. I let that inside part equal u, so this is going to become u squared. And I fixed my du already, so I can think of that as 3 cosine 3x. So look at how we went from something quite ugly to something that you have been integrating since we first learned to integrate, like day one integration. You weren't bad at this, okay? So when we integrate this, I'm gonna have 1/3. I'm gonna go up a power and divide by my new power. And then to finish it, I need to substitute.
So that's it for this one?
And so when I substitute, that's gonna give me, I need to put the u back, so that over, technically it's over 9.
Yeah, it's easier than the past.
Okay, so we're gonna leave that at this stage. As far as what you're gonna need to do now is go back on your homework from last night. If you integrated correctly, the only thing that should be missing is that fraction out front. That's the only thing. Like, I didn't give you any that you had to make weird substitutions, like you like rearrange it, like what we did on that second problem, where like we had to try to pick up the x. I didn't give you anything like that. So the only thing you're gonna have to do on a few of them is go back and say, okay, wait, like I was missing a 2, I need to put a 1/2, or something like that. That's the only thing that we need to clean up. So at this point, stop recording. So go ahead. Yes.
Let's go back to the very beginning. So pretty much we're just finding the f of u.
Yes. All right, guys. I'm not going to subject you to this anymore. I'm gonna